Well, I'm really sorry I can't be in class today to give the lesson, but this video and the ones that follow will serve the purpose of giving you the information you need, so hopefully you'll take good notes. The purpose of what you're doing today is really just, as you can see, the learning objective number 1 in Unit 2 is graphing quadratic functions. And there's 2 examples that I'm going to give you. I don't know how many videos it's going to take, but the first example, the vertex form, graphing a function, graphing a quadratic function using vertex form. Vertex form being the similar to the absolute value form where we have an A, an H, and a K, where the vertex, you can just identify whatever the number is that's being subtracted from the X is your H, and that's the X coordinate of the vertex. And then the number that gets added to the outside of this part here is your value for K. And when you know your H and your K, well, then you know your value of your vertex, the coordinates of the vertex. And then the A, that affects the graph by, if A is greater than 0, we know that the parabola, and by the way, all quadratic functions are shaped like a parabola. And then if the A is positive, the parabola opens up. And if A is negative, the parabola opens down. One thing that should be noted, it kind of looks like faces there. One thing that should be noted is that if A is a big number, like A is 2, bigger number than 1, A is 3, bigger number than that, the parabolas get a little bit more narrow. And then if A is, let's say, 1/3, the parabola would open up a little bit wider. So same with the negative. -2, if A is -2, then the parabola would open down. And again, it would be a little bit more narrow than if A was equal to -1. So that's a little bit of the background. Let's go ahead and look at our first example. Graph y equals 2 times the quantity x minus 3 squared minus 4. Now the way you're going to do this is in order of the way I show you. I want you to go ahead and plot the vertex. That's step 1. Or find the vertex. The vertex is HK. The H here is the number being subtracted from the x, so that's 3. The K is equal to -4. So if we plot that, 3 -4, we at least have our x, well, we have our vertex, and then we know that it opens up because of the 2 there. And like I said, it's going to be a little bit more narrow than normal. So let's just go ahead and draw the graph. So there we have our parabola, and we've graphed it, but we also want to make sure we understand how to identify certain characteristics. So we plot the vertex, step 1. Step 2, draw the parabola, label the vertex, 3, in this case 3 -4. And then another feature of all parabolas is that they always have an axis of symmetry, and the axis of symmetry is the one line that divides the left half from the right half, and it always goes through the vertex. And the equation for the axis of symmetry is x equals 3. Always identify the axis of symmetry in terms of an equation and not just the number 3. Okay, so there's the equation for the axis of symmetry. And then step 3, I want you to also, just to verify a couple points on the graph, I want you to pick a value of x that's just to the right of the x coordinate of the vertex. So just to the right of 3 would be 4, and just to the left of 3 would be 2. And then I want you to find a y coordinate for each of those points. And so y, again, is 2. And just use the equation here, replacing x with 4 in this case. So we have 2 times 4 minus 3 squared minus 4. And that 4 minus 3 is 1. 1 squared is 1. 2 times 1 is 2. 2 minus 4 is -2. So I did a lot of that here in my head here. So write that. 2 times 1 is 2. 2 minus 4 is -2. And then you should get the same exact value. If you replace x with 2, if you think about it, 2 minus 3 being negative 1, either you square 1 or negative 1, you're still going to get 1. 2 minus 4 then is also negative 2. So you can put a dot on the graph. If you put when x is 4, y is negative 2. And then when x is 2, y is also negative 2. So we have 2 more points on the graph to verify that we've got our graph going in the right direction. We found the right vertex. And then what else do we want to do with this? We want to find things like domain and range. So domain, well, the domain of all quadratic functions is going to be all real numbers. And then the range is the lowest y value to the highest y value. Lowest y to the highest y. Well, the lowest y is the y coordinate of the vertex here. So that's negative 4. We're going to include negative 4. And then there's no highest y, so it goes up to positive infinity. I'm going to finish up with the characteristics in the next video.